Hello everyone, welcome back to my channel. So from this video we'll start a new video series on digital communication. And in this video we'll see the classification of digital communication and basic block diagram of pulse code modulation. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. Right, so what is the difference between analog communication and digital communication is, in digital communication the message signal M of t is a rectangular pulse. M of t is a rectangular pulse which consists of zeros and ones. It is a rectangular pulse like this, which consists of zeros and ones. Okay, this is 0 1 0 1 and so on. Okay, so this will be your M of t in the case of digital communication. Okay, and C of t is same carrier, which is a high frequency signal AC cos of 2 pi FCT if you are using band pass data transmission. Right, so we'll see this we'll see about this later. Okay, so classification. First is the classification of digital communication. So digital communication is majorly classified into two types. One is baseband data transmission, and second is band pass data transmission. So these are the two types which you have in digital communication. And in baseband data transmission, it is again divided into two types. One is pulse analog communication, and second is pulse digital communication. So in pulse analog communication we have pulse amplitude modulation, pulse position modulation, and pulse width modulation. Okay, so these are the types of pulse analog communication. Similarly, in pulse digital communication we have pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. Okay, so pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. Pulse amplitude modulation, pulse position modulation, and pulse width modulation. Okay, so these are the classifications of pulse analog communication and pulse digital communication. Similarly, band pass data transmission is also classified into two types. One is binary signaling, and second is M-array signaling. So in binary signaling we have ASK, PSK, and FSK. That is amplitude shift keying, phase shift keying, and frequency shift keying. Okay, so frequency shift keying. Similarly, amplitude shift keying and phase shift keying. In M-array signaling we have QPSK, okay, 8 PSK, 16 PSK, 32 PSK, and so on. Along with that you have QAM. Okay, 8 PSK, quadrature PSK, and 16 PSK, 32 PSK, and similarly QAM, quadrature amplitude multiplexing. Okay, so all these topics we have to learn in digital communication. right? So what is the difference between baseband data transmission and bandpass data transmission is, so output of this baseband data transmission is a rectangular pulse, right? So m of t is rectangular pulse, and this rectangular pulse is transmitted in guided propagation, that is through some cables, right? When you are not transmitting, when we are using digital communication but not transmitting the signals over long distances, you are not transmitting signals over long distances, but you want to use digital communication, then you can make use of baseband data transmission. So base means low, band means frequency. So low frequency data transmission, so that is why it is called as baseband data transmission. Okay, so directly you can transmit the rectangular pulse, which is the message signal of a digital communication. So message signal of digital communication is a rectangular pulse, and these rectangular pulses are directly transmitted through cables, okay, at low frequencies. Then such type of propagation or such type of data transmission is called as baseband data transmission. In bandpass data transmission, we make use of this carrier, high frequency carrier. So high frequency carrier is used to modulate, high frequency carrier is used to modulate the rectangular pulse. Okay, so you are going to modulate the signal and passing it through free space, and that is long distance, for long distance transmission. For long distance transmission, if you want to use digital communication, then you have to use bandpass data transmission. Okay, so this is the major difference between baseband data transmission and bandpass data transmission. In baseband data transmission, the message signals, that is rectangular pulses, are directly transmitted through cables. Okay, so this baseband data transmission is used for only short distance communication. Similarly, bandpass data transmission make use of carrier to modulate the rectangular pulses, so it is used for long distance transmission. Okay, so in both the cases, rectangular pulse is the message signal. Okay, so next we'll discuss about pulse code modulation. Okay, so this is the first digital modulation technique. Okay, so and it is widely used modulation technique. Okay, so widely used digital modulation technique. Right, we'll see the basic block diagram of pulse code modulation first. So the first element of this pulse code modulation is sampler. Okay, sampler, and output of this sampler is given to quantizer, and output of quantizer is given to encoder. Okay, so through encoder it is transmitted through the channel. So in the channel we have regenerative repeater. Next is also regenerative repeater. So we have a series of regenerative repeaters. And then next it is transmitted to receiver, okay, from channel, and the first element of receiver is regenerative circuit. Regenerative circuit, and then it is passed through decoder, and finally it is given to low pass filter. Okay, so all these are the elements of a pulse code modulation technique. Okay, right, so this is transmitter part, this is channel, and this is again receiver part. This is your original message signal M of t. Right, we'll see each and every block now. Okay, so we'll see each and operation of each and every block. So M of t is an analog signal because only analog signals exist in nature. Okay, so if you are suppose take an example of your voice signal. Your voice signal, if it is converted into electrical form, it is a continuous signal because you are talking continuously. Okay, so where you are decreasing your amplitude and increasing your amplitude. Okay, so it is continuous in nature. All practical signals are continuous in nature. So in order to have digital communication, we are converting that continuous time signals into discrete time signals. Okay, and from discrete time signals we are converting it to digital signals. Okay, so this is the process going on. So first continuous signals has to be converted into discrete time signals by using a process called sampling. By using a process called sampling, we are converting continuous time signal into discrete time signals, and discrete time signals are converted into digital signals by quantization. By process called quantization, we are converting into digital signal. Okay, so this digital signal which is obtained is converted into rectangular pulses. This digital signal which is obtained is converted into rectangular pulses by a process called encoding. Okay, so output of this encoder is your rectangular pulses. Right, so this is the process going on. So first stage is sampler. Sampling is used to convert continuous time signal into discrete time signal. Continuous time signals are converted into discrete time signals. If this is your continuous time signal, then the output of sampler will be like this. Okay, so it is again a continuous. If you add the amplitudes, it will be same as your message signal. Okay, so output of this sampler will be a discrete time signal. Okay, so discrete time signal is given as input to quantizer. So quantizer, what will it do? So it will quantize, that is rounding off the each sample, and rounding off each sample to quantized level. So this is the operation of quantizer. That is, the output of this sampler, may be of this form. Right, redraw again. Okay, so this amplitude may be 0.3 volts, 0.9 volts, 1 volt, 0.6 volts, 0.2 volts. Okay, so what does quantizer do is, quantizer, based on the quantization level, it rounds off these amplitudes of the samples. So these amplitudes of the samples to the nearest quantization level. So suppose if your nearest quantization level is 1, okay, from 0 to 0.5 the quantization level is 1, and from 0.5 to 1 the quantization level is 2. Let us think this. Okay, so we'll discuss about how to quantize this later. Okay, let us think that if the amplitude value of the sampling, okay, of the sample is between 0 and 0.5, it is rounded off to 1 volt, and 0.5 to 1, it is rounded off to 2. So this 0.3 is in this range, so it is rounded off to 1, and 0.9 is in this range, so it will be rounded off to 2, and this is 1, so it is also rounded off to 2, and then 0.6 is also rounded off to 2, and 0.2 is rounded off to 1. Okay, so if you see here, it is the quantized message signal. Okay, so quantization means rounding off to the nearest integer value. So instead of 0.91 or 0.6, 0.2, so you are going to have the nearest rounded off value. So 1, 2, 2 and 1. Okay, so this process of rounding off the amplitude values of the samples is called as quantization. Okay, so in my next video I'll explain you clearly about what is quantization. Okay, then encoder. So encoder is an A to D converter. Encoder is your A to D converter. Okay, so it converts the amplitudes, the rounded off amplitudes, into bits, that is ones and zeros. It is used to convert the amplitude values, which is quantized amplitude values, into corresponding bits. Okay, so that is why when it is converted into bits, the output of this encoder is a rectangular pulse, because you have only bits, either ones or zeros. So ones and zeros can be represented in electrical form as rectangular pulse. Okay, so I'll explain you. Okay, don't worry, quantization and encoding both I will explain you clearly in my next video. Then so this output is a rectangular pulse, and that rectangular pulse is passed through channel. As I have told you, pulse code modulation is an example of baseband data transmission. That is, it is passed through a guided communication. Okay, that is, it is passed through cables. Okay, so guided communication. So it is passed through cables. So in between you will have regenerative repeaters. Why regenerative repeaters are used? Because due to transmission from transmitter to the receiver in the channel, noise may creep in. Okay, so noise may creep in, due to which the amplitudes of this rectangular pulse get decreased. Okay, so amplitudes of rectangular pulse will get decreased. So in order to restore the amplitudes, in order to restore the decreased amplitudes of this rectangular pulse, we will use the regenerative repeaters. They are just like your amplifiers in the case of analog communication. Okay, so number of regenerative repeaters. So number of regenerative repeaters depends on distance between transmitter and receiver. Okay, so if the distance between transmitter and receiver is more, then you require more number of regenerative repeaters. That's all. So number of regenerative repeaters to be used depends on distance between transmitter and receiver. Then through the channel it will be passed to the receiver end. So the first element or the first circuit of receiver circuit is regenerative circuit. So regenerative circuit will eliminate the noise. Present in the rectangular pulses. Okay, so it is used to eliminate the noise present in the rectangular pulses. Okay, we'll see later how it will eliminate. And decoder is D to A converter. So until now the output or the output of regenerative circuits is still this rectangular pulse only. So this is a D to A converter, that is these rectangular pulses are again converted into samples like this, right? So these samples which is obtained at the output of sampler, the same samples you are going to get at the output of this decoder circuit, which is a D to A converter. Okay, so this low pass filter is a reconstruction filter. Okay, so it is used to restore or reconstruct the amplitude of the message signal based on the samples. So based on the samples, so it is going to reconstruct the message signal like this. So based on the amplitudes, it is going to reconstruct the signal like this. So same signal based on the amplitudes, you are going to have the reconstruction filter. So that is how your message signal is transmitted from transmitter end to the receiver end by using pulse code modulation. Okay, I'll tell you again, very simple. So M of t is passed through sampler first. Sampler converts continuous time signal into discrete time signal, and the output of discrete time signal is a sampled signal, right, whose samples are having random values like this. Okay, so these random values, random amplitudes of the samples are converted into nearest rounded off values, that is called as quantized values by using quantizer. Okay, so the output of quantizer is given to encoder, which is a to D converter. So based on the quantization levels, it is going to convert that into bits, that is ones and zeros. That is the output of A to D converter is a rectangular pulse. This rectangular pulse is passed through channel. In channel we have regenerative repeaters, because due to noise the amplitude of this rectangular pulse get suppressed. So in order to restore the amplitudes, we are having regenerative repeaters. So number of regenerative repeaters depends on the distance between transmitter and receiver. If the distance is more, we require more number of regenerative repeaters. Then it is passed through the receiver circuit, where you are having the first stage as regenerative circuit, which is used to eliminate the noise, because it is traveled long distances and noise will be added in the communication channel, right? So output of regenerative circuit is a pure rectangular pulse again. Okay, so pure rectangular pulse, that is, it is consisting of ones and zeros. Then it is passed through decoder, which is a D to A converter. So this digital data is converted into its corresponding analog data, that is digital to analog converter. It is converted into analog digital to analog conversion, that is, it is converted into samples again. Then it is passed through a low pass filter, which is a reconstruction filter based on the amplitudes. Okay, based on amplitudes, because our low pass filter consists of RC circuit. So based on the amplitudes, charging and discharging of capacitor takes place, and therefore you will have the amplitude of the samples. Okay, so amplitude of the samples are going to be traced, so that traced output will be your message signal. Okay, so this is how a message signal is transmitted from transmitter to the receiver by using pulse code modulation technique. Okay.